We wanted to find out how pulleys work.
Can you tell us about your experiment?
Sure. First, each group was given a 500-gram mass, 2 double pulleys, a cup, some string, and some pennies. We hooked the 500-gram mass to the bottom of the pulley system that we constructed. Their combined mass is called the load.
What did you do with the pennies?
We kept adding pennies to the cup until the load was lifted. We then placed our cup on a balance to find the total mass that it took to lift the load. Once we collected our data from 2 strings, we repeated with 3 and 4 strings.
Did each group in the class get the same data?
Not exactly, so we shared our data and took the class average of the total mass that it took to lift the load for each number of strings.
When you analyzed your data, were you able to come to any conclusions?
Yes, after putting the class averages up on the board, it was pretty obvious that the more strings we used, the less mass we needed to lift the load.
How did you calculate how much mass you needed for each string?
We counted the number of strings that supported the load and divided the combined mass by the string count. We saw right away that there was a problem when we did our first calculation.
What was the problem?
Our mass being lifted was 545 grams when we had only 1 string. It should have taken 545 grams to lift it. Instead, it took an average of 571 grams. We also found the same thing in each of our other calculations.
Could you have collected your data incorrectly?
That's what we thought at first, or that we had made an error in our arithmetic. Our teacher gave us a hint. We realized that there was friction in our pulley system. Friction slows things down and makes it more difficult to lift.
That's why you needed more mass to lift the load.
Right. We concluded that you can find approximately how much mass is needed to lift the load by dividing by the number of strings, but you definitely have to consider friction.